Now all we have to do is derive these Q as a function of t and I as a function of t equations for a discharging capacitor. So in our discharging situation, what we have is this. We've had this capacitor, we close this switch, the capacitor gets all charged up right there, and then what we're going to do once it's fully charged, we're going to open this switch, so it's back open again, and then at that same instant, we're going to close this switch. So now all we have in the circuit, it's basically like just getting rid of this whole thing. We've just got the capacitor and the resistor. So notice that what I've got here is I've got my, I'm going to use the loop rule again. Let's go ahead and do that. Loop rule. I'm going to suppose that the current's going that way, which it will. So I've got, starting right here, I'm going across that way. So I've got delta V across my capacitor is going to be Q over C, and it's going to be positive because I'm going to from a low to higher potential. And then it's going to be minus I R equals 0. Now, this is going to be a lot easier. There is one catch, though, that you have to be very, very careful of. This current right here, I'm going to replace the current. You might say, okay, don't I just do this now? I is dq dt. Well, it's almost dq dt, but what's happening is you can ask yourself, is the charge decreasing or increasing on the capacitor at this point? Well, if you said decreasing, you'd be right. So what happens is the current is a positive value. It's going to be the opposite. Notice that. I'm going to circle that right there so we note that that's very important. The current is the opposite of this negative value. dq dt is negative, and current's going to be positive. So we got it. We must add that little negative sign there, or none of this will work. And a lot of textbook authors kind of just gloss over that fact. So back to doing this and trying to keep the right side clean. I'm going to have Q over C plus, or I'm just going to put this on the other side, will be, becomes plus and plus, will become dq dt times R, again keeping the right side clean. That gives me Q over RC equals dq dt. And then we'll end up with, want to get all the Q's on one side, so I'll get dq dt, whoops, I dropped the negative sign there, that becomes negative, and that becomes negative. So dq dt, put the dt on this side, put the RC over there, what I get is dt over RC, and I'm going to put the negative side on that side too, equals dq over q. And I'm going to stop right there because this is a lot easier than the last derivation. And when you graph this, I'm going to leave the graphing for you as a problem, but this is a very, very similar derivation and very, very similar graphs, also exponential. So try that as a problem, and that's all for this lecture. All right, we'll see you next time.